Great, it's recording now. Today we're going to talk about section 3.5, derivatives of trigonometric functions. For that, let me remind you about these two functions, sine of x over x and cosine of x minus 1 over x. The first one, we saw this function already before, right? When you graph it, this is what you get. And if you take the limit as h approaches 0 of this function sine of h over h, we know that that result is just 1, right? 1. Welcome, CG. Welcome, Grace. We just started. We are trying to remember these basic results from these two functions, sine of h over h, cosine of h minus 1 over h. If we take the limit of this function whose graph is this, right? And you may say, Professor, how do you know the graph is that? Well, guys, you have Desmos graphing tool, right? So whenever you want to check, verify that the graph is indeed what it's supposed to be, right? Just graph it there, y equal sine of x over x. I could have written sine of h over h. Remember, the variable is not relevant for this representation of a function, right? It's just a placeholder, so I'm using x. Great. So you can see that this is this, right? Now, you may say, Professor, this looks taller than this. Yeah, it's because of the scale, right? Mathematicians sometimes play around with the scales so that this can be seen clearly that the value here is 1, right? Yeah, but this is the shape. That's what matters. Okay, great. So now let's recall this result, right? Oscar, welcome. We are going over derivative of trigonometric functions. I hope you're doing well. Okay, so what is important here is that if you approach the graph of this function from the left towards 0, right? From the left, the output values are going up to 1, right? And if you approach from the right to 0, also the output values are going up to 1. So we know that this guy is equal to 1, right? So let's write it 1, right? Limit of sine of h over h as h approaches 0, 1. Now, what about this guy? What is the limit of cosine of h minus 1 over h looking at this graph? Anybody could guess what this limit should be or could tell us by tracing the graph, which is this? What should be this limit? The graph is here. Approach from the left, approach from the right, and figure out the limit. Okay, so let me graph this here so you can have a confirmation that this is indeed the graph, and you can have this graph whenever you need it, right? So whenever you need graphs, then use this. Now, this is the graph of this guy, right? You may say, Professor, this looks taller, lower here than this, right? Yeah, it's because of the scale. They have played around with the scale on the y-axis just to show that this guy comes down to 0, it comes down to 0 clearly, right? But this is the graph, the same graph, right? Up here, down here. All right, great. Someone is figuring out. Sarah, very good. Excellent, Sarah. Yeah, very good, right? Sarah is saying the limit of this should be 0. Limit of cosine of h minus 1 over h as h goes to 0, 0. Yeah, very good. Because if you go and approach 0, the input value 0 from the left, your output values are coming down to 0. And if you approach 0 from the right, the output values are also going to 0. So this convergence from the left going to 0, from the right going to 0. So the limit exists at is equal to 0, right? So this limit equal to 1, this limit equal to 0. We're going to use these two facts to figure out the derivative of trigonometric functions, in particular the derivative of sine. But together with these two results, we are going to need one more result that comes from trigonometry. And this is a formula that you might have seen when you took pre-calculus. Sine of A plus B, what is that equal to? Turns out this is just equal to sine of A multiplied by cosine of B plus cosine of A multiplied by sine of B, right? This is something comes from trigonometry when I use these two. Okay, so now it is time to figure out the derivative of this basic trigonometric function first. F of x equals sine of x. This is the sine function. Let's find the derivative of f of x equals sine of x, right? Let's start with that. I'm going to show you step by step how mathematicians figure this out, okay? So, derivative of the function sine of x with respect to x using the definition via limits should be is equal to this, right? The limit of this function, sine of x plus h, right? Minus sine of x all over h as h approaches 0, right? This is the derivative using the definition via limits. Now, next, I'm going to expand this using this identity, okay? That comes from trigonometry. So they should be equal to limit as h approaches 0 of sine of x cosine of h plus cosine of x sine of h, right? Minus sine of x, all this divided by h. All this divided by h, and we are supposed to take the limit of that as h approaches 0, right? Yeah. Okay, guys, so this guy is just this, right? Expanded using this formula. X plays the role of A, H plays the role of B. Next, what you're gonna do is this. Mathematicians, in an attempt to recover these two forms, this form and this form, they put together these two terms, this guy, the first one, the third one. I'm going to do it here. Sine of x cosine of h minus sine of x, right? And this guy, they wrote it at the end. Basically, they rearrange these terms, right? Rearrange these terms. All right. So now that I have rearranged this here, I am going to factor out sine of x. Look, sine of x is here, sine of x is here. I factor out sine of x. Sine of x out. Sine of x into sine of x cosine of h, just cosine of h, right? Minus, minus. Sine of x into sine of x, 1, right? 1. Plus cosine of x multiplied by sine of h, all divided by h, right? Yeah, great. Now, next, notice that if you separate this part from this part, right? I'm gonna look here for you to see this part from this part. This is what you will get. Limit as h approaches 0 of sine of x multiplied by cosine of h minus 1 over h, right? Over h, plus the limit as h approaches 0 of cosine of x sine of h over h, right? Follow guys? I just distribute the limit over the sum after this dividing by h each of these two terms, and I get this, right? And now notice that this guy, this guy, sine of x, behaves like a constant for this variable h, right? The variable is h, this is the variable part, but this sine of x behaves like a constant. So I can pull this out here. Pull this out here, right? So we're gonna have sine of x here outside multiplied by the limit as h approaches 0 of this part, right? Of this part. And Professor, why you are trying to get this? Well, because I have this result here, right? In the top, look, I have this guy, is 0. All right, similarly, here, notice cosine it's just a constant, right? A constant. So for h, which is playing the role of the variable, right? So you can take this out. So cosine of x multiplied by the limit as h approaches 0 of sine of h over h, okay? Now, finally, right? This limit was calculated before, right? Before sine of x, this guy, this limit was calculated before, is just 0, right? You see this guy, 0. I'll put it there, 0. And this other limit also was calculated, right? The limit of sine of h over h as h approaches 0 was calculated before. We recall this. It's just 1, right? 1. So putting everything together, guys, believe it or not, look what happens. This guy, sine of x times 0, is just 0, right? 0 disappears. This part disappears. 0. This stays. Cosine of x times 1, cosine of x, right? So this is telling me that the derivative of this function, sine of x, believe it or not, guys, is just cosine of x, right? Cosine of x. Let's write it once and for all, right? We show this mathematically, so no doubt. Derivative of sine equal cosine. And from now on, guys, I want you to memorize this, the result, because we're going to use this so much that if you don't memorize it, you have to constantly look at tables and results, right? It will pay off to memorize it. Derivative of sine of x equal cosine of x, okay? All right, now, similarly, right? Similarly, mathematicians figure out what is the derivative of cosine of x, right? I'm not gonna do this mathematical proof again, because remember, guys, this course is more about how we apply these results, right? How we go over applications. This was to show you, right, that in mathematics, all the results, they have a background, right? A foundation, a justification, right? But similarly, right, if you do this reasoning similar as I did with sine, with cosine, it's not difficult. You will show that the derivative of cosine is equal to minus sine of x, minus sine of x. Okay, so mathematicians figure this out. We're gonna take it as a fact. The derivative of cosine of x equal minus sine of x. Professor, minus sine of x, shouldn't it be just sine? Is this minus a typo? Unfortunately, no, guys. It's the minus sign is required there. You know, this function sine and cosine, they behave differently, right? They're very similar, but you know that cosine of 0 is 1, sine of 0 is 0, right? Cosine, trickier to deal with. That is why there is a negative sign there. So this other result, the second result, also please memorize, because we're gonna use it a lot. So derivative of sine of x equal cosine of x. Derivative of cosine of x equal minus sine of x. Okay. All right. So now I'm gonna show you how, using these two facts, right, we can take derivative of trigonometric expressions containing sine and cosine, or both at the same time. I will show you. Example 1. Suppose they ask you to take the derivative of this function, 3 times sine of x, 3 times sine of x. Let's do it together. Notice this is a constant, right? The number 3, real number 3. We know that we have a property called the constant multiple rule, right? Which says that constants can be taken outside of the derivative, so that we focus on taking the derivative of a function, right? And we multiply the result of this just times 3. But what is the derivative of sine of x? Anybody could say in the chat, what is this derivative of sine of x? We just show it, right? I see you guys are tuned. Very good, Sarah, Adriana, Oscar. I'm glad you guys are following your tune. The derivative of sine, we said, right, from now on, cosine, all Grace also very good. Yeah, try to memorize that, guys. If you walk away from this calculus course knowing that derivative of sine equal cosine, derivative of cosine equal minus sine, it will be great, because you're going to use this a lot against in calculus 2, in calculus 3. All right, derivative of sine cosine. So I write cosine, and I'm done. 3 times cosine of x is the derivative of 3 sine of x. Very good, very good. Here is another one. Number 2, they are asking us to take the derivative of this function, twice cosine of theta minus 7 times theta with respect to theta. Guys, warning, do not confuse this theta with 0. It's not 0, it's theta. It's a letter from the Greek alphabet, alpha, beta, theta, right? So let's do this, right? First, allow me to distribute by derivative, right? Over this difference. Remember, derivatives, they behave nicely over the sum, over the difference of two functions. So let's do that. Minus, minus here. And then I have to take the derivative with respect to theta of this 7 multiplied by theta. Very good. Now, 2 is a constant, it's a real number. I can take it outside of the derivative, and I focus on getting this derivative of cosine of theta with respect to theta, minus 7 is a constant, comes out, derivative of the identity function theta with respect to theta. Now, question for you guys. What do you think should be this? Derivative of cosine of theta based on the facts that we posted, right? What should be derivative of cosine of theta? See? I see. Adriana, Oscar, very good. Sarah, very good, guys. I think you are tuned, right? It's a tricky one. Minus sine of theta. Very good, right? Very good. And this is minus 7. What's the derivative of the identity function? Anyone on the chat? Yeah, Grace, very good, Grace. Minus sine of the x, right? We have this, right? Minus sine of theta. Yep. And here the derivative of theta, since it's the identity function, what should be that? Anybody in the chat? Derivative of identity function. Oscar, very good. Very good, Adriana, is 1, right? No matter what variable you are using, even if you are using letters from the Greek alphabet, this guy has to be 1. That is the derivative of the identity function, independent of what letter you are using to represent your variable, right? So this is it. And finally, just simplify this. Look, 2 times negative 1 is negative 2 sine of theta minus 7 times 1, 7, right? That's it. This is the derivative of this function, right? Very good, guys. Very good, very good. Now, let's talk about the product rule, right? Combined with this facts that derivative of sine equal cosine, derivative of cosine equal minus sine, right? Let's see how this works. All right, if they are asked to do something like this, quickly, you notice that they're asking you to take the derivative of a multiplication, a product of two functions, right? Let's use green color here. This function times this function, right? Don't have to see there is a product there. So quickly think of the product rule. Remember, derivatives cannot be distributed over the factors, right? Instead, there is a so-called product rule, which I'm gonna recall you guys here. Let's right here, recall the product rule that also you should memorize. We're gonna use this rule a lot, so recall product rule. Product rule. The derivative of f times g is equal to derivative of f times g plus derivative of g times f, right? Comment here, in some textbooks, they write first f and then the derivative, or they rearrange the order of these factors, but don't worry about that, guys, because remember, multiplication is commutative. The order of the factors does not change the product, right? This formula is symmetric. I kind of start always with the derivatives because I'm trying to emphasize that you have to take the derivative somehow, right? These guys are without derivatives. All right, so applying the product rule, then identify this guy with the f function, this guy with the g function, then basically we have to take the derivative of this, right? 5x to the third times sine of x, right? Let's write it within parentheses. So clearly we will know that this guy will play the role of f, this guy will play the role of g, right? The role of g. So let's do it now. So we're going to start by taking the derivative of this guy, right? So, but the derivative of this guy, derivative of f, right, is what? 5x cubed derivative. Anybody could tell us what's this derivative, the one that we're going to start with? Derivative of 5x cubed in the chat or verbally. I see. Very good, Adriana. Very good, Oscar, Sarah. Yeah, I see you guys are tone and sharp. Yeah, taking derivative of monomial, polynomials should be something that you should do quickly, right? It's gonna help you a lot for what is coming. So the derivative of this guy is just this. 5 comes outside, and then the derivative of x cubed is 3 times x, 1 less stays as exponent, right? 3 minus 1, 2. Well, 5 multiplied by 3, 15, 15x squared. This is the derivative of this guy, the derivative of f, and that is what I will write first. 15x squared, right? This guy, derivative of this, derivative of f. Now I'm supposed to multiply that by g, the other function without derivative, as it is, right? Sine of x. Here, great. Then plus. Now time to take the derivative of g, derivative of this guy. But anyone could tell us in the chat, what is this derivative? Derivative of sine of x. I see, 2 students. Very good, Oscar, very good. Sarah, 3 students. Adriana, very good, right? Derivative of sine of x is equal to cosine of x. Cosine of x. Yeah, I'm glad you guys have memorized this. Derivative of sine, cosine. That is the derivative of this guy. So cosine of x here. Derivative of g, right? And then multiply by f as it is. F as it is just this 5x cubed, right? And pretty much this is it, because now we just have to simplify and present our final answer. For that, let me tell you something that mathematicians very often do. Mathematicians like to write first, when they have to write the multiplication of two functions, first up front, they write the functions that they consider to be simple. Look, a polynomial function compared to the trigonometric function simply, right? So they will write this up front. The complicated one following, right? This way. Plus, here, look again, following the agreement I explained, right? The polynomial function should lead first. The simple function, and the most complicated function, they push it to the right, cosine, right? So this is what you may see on the multiple choices, right? The multiple choices as the derivative of the product of these two functions, okay? All right. Okay, guys, time to practice now. Time to practice. So let me choose good exercises for you to practice here. This one. A lot of exercises, probably we will go over all of them. So you guys will have a good background for your homework. Homework is a little bit tricky. So why don't you try this? And I will rewrite this so you can clearly see what's going on here. They want you to find the derivative of this function, r equal 9 minus theta cube multiplied by cosine of theta, okay? You are supposed to find the derivative of this guy, right? The derivative with respect to theta of this 9 minus theta cube cosine of theta. Can you try this? Yeah, hint, first distribute your derivative, right? Then apply product rule here. Product rule, look, with this playing the role of F, this playing the role of G, right? And then combine everything, right? Yeah, try. And see if we can get it done. New homework will appear. I have included a video in one of the homework to help you out. I created a video myself to explain, to help. Yeah, remember derivative of constant is just 0. So this piece is going to be a 0. So you really have to focus on taking the derivative of this part, which is a product of the function, right? Yeah, very tricky, very tricky. Okay, so okay, let's I see. Students posting answers. Very good, very good. Oscar, Ruby, Sarah, excellent guys. I think you got it. Yeah, very good, excellent. Yeah, you made my day, guys. Very good, very good. Yeah, it's not that simple, right? That's why we're gonna do this stuff carefully, slowly, but doable in the end if you follow the rules. Okay, so this derivative, if you distribute the derivative over the difference, it should be equal to the derivative of the constant function 9 with respect to theta, which is the variable here, right? Minus the derivative with respect to theta of this product of these two functions, theta cube multiplied by cosine of theta. I see more answers are coming up. Sarah, yeah, Oscar, yeah, Oscar, Sarah, yeah, good. The first one was great. Yeah, check the signs, yeah, but the first one you posted correct. Yeah, Gray is also good. Yeah, good, guys. We will clarify that we gotta be careful with the signs there. Okay. So now notice this derivative is the derivative of a constant, right? So that derivative should be just zero, right? Zero. The derivative of a constant function, no matter what it is just zero. So this guy I can eliminate, right? Disappears. So what I'm left with? I'm left with a derivative of theta cube multiplied by cosine of theta with respect to theta, right? With respect to theta. And this is together with this negative sign outside. Very careful with that sign. I think that's creating confusion. All right, so now let's identify this theta cube, this cubic function with f, and this cosine of theta with g, okay? And let's recall our product rule. Recall product rule. Product rule says that the derivative of the multiplication of two functions is equal to the derivative of the first factors times the other factor plus the derivative of the second factor g multiplied by the first factor as it is f, right? This is the product rule. So let's do that. Notice there is a negative sign there. Because of that, I'm going to keep parentheses, better brackets, I think, right? To write down the result of this here and then use this sign as a multiplicative factor. All right, so derivative of this first. What is the derivative of this? Anyone could tell us what is the derivative of theta cube? With respect to theta. The derivative of theta cube. Very good, very good. Yeah, very good, Adriana, Sarah, right? Excellent. This is just 3 times theta squared, right? 3 times theta squared. Excellent, excellent. 3 coming down, 1 less stays exponent. 3 theta squared. I'm gonna write it within parentheses. This is the derivative of f times g as it is without derivative, the cosine of theta, right? Very good. Plus derivative of g now, derivative of this guy now. But what is the derivative with respect to theta of this guy, cosine of theta? Anybody in the chat? What is the derivative of cosine of theta? Remembering the two minus sine of theta. Very good, Adriana. Very good. Sarah, Oscar, Grace, right? Minus sine of theta, right? The tricky one. Minus sine of theta. Excellent. This is this, right? So this is what goes here. The derivative of g function minus sine of theta. I'm going to write it within parentheses. Times the other function f as it is. This one, right? Yeah, this very tricky, this question. Yeah, now let's just put things together. Let's distribute the multiplication by -1, right? Remember, there's like a -1 there multiplying over. So this will make this first part negative, -3 theta squared cosine of theta, okay? And here, look, when you multiply by -1, this second term, negative times negative, positive, right? Positive, positive. Positive and negative, negative, but negative times negative, positive, positive. And here, I want you to remember that mathematical agreement, right? The mathematicians often follow. They write the simple functions, what they consider to be simple functions, such as this cubic function first, and the complicated ones, the trigonometric functions, following at the end, right? That's it. So this is what you should look for among the choices, right? And I think it's there. Very good, guys. Look, it's here, right? Look, it's presented in this form. Yes. Very good, very good. If you don't have experience dealing with trigonometric functions together with algebraic functions, do it slowly, and then you will be able to identify your answer. Okay. All right, guys. Very good, very good. So now let's move forward. Okay. Now, sometimes they're gonna ask you to do this, but they will ask you to go one step forward. One step forward. What do you mean? Well, they will ask you to find equation of the tangent line, right? So for that, you will have to use the derivative to find the slope. And then with that slope, you should be able to find the equation of the tangent line, right? What kind of problems are you talking about, Professor? Well, I'm talking about this kind of problems. Look, for example, this. Find the tangent to y equal 2 minus sine of x at x equal pi. For example, that, right? How to figure out the equation of the tangent line. I'm going to give you an example, and then we will go back to this, right? This and this. This is another one. Look, two. There are two there. All right, so let's go back to the lecture. Let me show you. I have this here as example 4. It says here, example 4, find the equation of the tangent line of y equal 2 times sine of x at x equal pi, right? So basically, they're asking you to figure out the equation of the tangent line to the graph of this guy at x equal pi, right? Yeah, if you want to kind of visualize what's going on there, you can graph this, right? If you want to, some students, they like to see a visualization of the problem before going into the problem, right? Look, this is the graph of y equal twice sine of x, right? And they are asking you to figure out the equation of the tangent line at x equal pi. Pi is equal to 3.14. It's going to be somewhere here, perhaps here, right? And then there is going to be a tangent line there, right? A tangent line like this. They want the equation of that tangent line, right? The equation of the tangent line at x equal pi, right? Very good. So let's do it together, okay? So first, we're going to find the derivative of y with respect to x, right? Because we want to figure out what is going to be the slope of that tangent, right? So we're going to find this derivative first. But notice number 2 is a constant, comes out. I focus on taking the derivative of this guy, derivative of sine of x, right? But what is the derivative of sine of x? Anybody on the chat? Derivative of sine of x? It would be great, guys, if you all memorize it, because we're going to use it so much that it will pay off to memorize this, right? Derivative of sine of x. Remember, there are two results. Oscar, Sarah, very good, guys. Cosine of x, right? Cosine of x, excellent, excellent. Derivative of sine, cosine. That's it. Now, this is going to give you the slope of the tangent line at any value of x, right? But the value of x that they want you to consider is pi, right? So this is the slope of the tangent line at x, right? The slope of the tangent line at any input value x. But now at x equal pi, the slope of your tangent line should be equal to what? 2 multiplied by cosine of x, but x is pi, so substitute pi there. Now, let's get this in our calculator, right? What is 2 times cosine of pi? Cosine of pi, if you remember per calculus, in the unit circle, this guy just tells you that pi is here, right? Pi. So this has as coordinates -1, and remember, in the unit circle, the first coordinate is cosine, right? First coordinate is cosine. So cosine of pi should be -1, right? 2 times -1. So slope of the tangent line is 2 times -1, -2. Now, if you don't remember this stuff from the unit circle, guys, okay, you can compute this in a calculator as well, but just be careful. You have to work in radians, right? Remember, this pi doesn't have the little hollow circle on the top. It means that it's in radians, right? So if you're going to compute this using the calculator, be careful. Let's do this. 2 cosine of pi. Pi is always here. Any scientific calculator has pi embedded there. It's one of the keys. But notice, right? If this is the result for 2 cosine of pi degrees. So don't get confused. This is not the one we're looking for, right? We're looking for the one that considers pi as radians. So 2 times cosine of pi radians, look, -2. Same as I got here, right? Same. So if you're going to use a calculator, just make sure to work in radians. Maybe we should write this as a note, okay? Note. If you use a calculator, make sure you were working in radians, right? Note. If you use a calculator, work in radians. Work in radians, right? In other words, set the calculator to work in radians, right? Work in radians. Yeah, be careful there when you take the exam, especially. All right, so now this is -2. But now this is not it, because this is just the slope with a slope equal -2. And point, I have a point, which is this, pi, comma, I don't have the partner of pi, but we have the function. So we can plug this pi into the function, and we should get the partner of pi, right? 2 sine of pi. But what is this guy? 2 sine 2 multiplied by sine of pi. Use the calculator again. Remember, use set it up in radians, right? And this sine of pi should be a 0 in the calculator. 2 times 0, 0. So the point is pi comma 0. Professor, could you show how you get this in the calculator? Sure. 2 times sine is here, of pi. You can type pi or just pick it up from here. And again, guys, you see, this is showing this if you work in degrees, but remember, you're supposed to work in radians. 0, right? 0. So just be careful there. If you use a calculator, there's nothing wrong with that, but just be careful that you're doing the computations in radians, right? For these trigonometric forms, working radians. So 0, right? 0. So I got the point and I got the slope, right? So now, having the point and having the slope, you should be able to compute the equation of the tangent line following this point slope form, right? Or there are other methods to follow any method you feel comfortable with. This is x1, this is y1. The slope we know is -2. So we will get y minus y1 is 0 equal slope is -2. X minus x1 is pi. So work this out, 0 disappears from the scene, right? 0. This minus 2x. -2 multiplied by minus pi. Minus times minus is plus. 2 times pi, 2 pi. Mathematicians like to leave pi alone. This is what they call the exact form of the equation of the line. So just leave it alone. This should be what you should look at multiple choices, right? This form. Pi, leave it alone. Don't substitute it for 3.14. Just leave it there. Okay, guys. So this is how you proceed in case they ask you for the equation of the tangent line, right? Yeah, probably it's weird to do this with trigonometric functions, but slowly, right? If you work with a calculator again, make sure you work in radians. Maybe we should highlight it's important. Otherwise, it's not gonna be right. Right. Okay. So now something for you to practice, like a couple of exercises for you to practice and master this form. Here, I think is this guy's was one cosine. This one. Try this. Can you try it? I'm gonna give you time. So try this guy. Find the tangent. This means equation of the tangent line, right? Equation of the tangent line. Of this y equal cosine of x, the graph of this, right? At x equal pi over 2. Can you try this? Hint, start by taking the derivative of y with respect to x, right? Start there with this, because this will give you the slope. So start with this. Once you have this, then you substitute your slope at x equal pi over 2. Then you get the slope. Then you have a point, the first coordinate, substituting into the function, you get the second coordinate, you get the point, right? Try to follow what I did on the example. And as a reminder, right? The derivative of sine is equal to cosine, but the derivative of cosine is equal to minus sine, right? Minus sine. Be careful there. And again, if you want to visualize this problem, right? If you want to have an idea of what this is all about, well, they are asking you to figure out on the graph of y equal cosine, what is the equation of the line tangent at x equal pi over 2. So this is pi over 2 should be somewhere there, so something like this, right? It's going to be some line like this. They're asking you for the equation of that line, that tangent line, right? And we have a way to find it, right? And try to remember all this stuff when you do your homework, okay? Gonna help you a lot. I see 3 students figure this out. Number 9. You guys made my day. Excellent, excellent. Well done. Grace, Sarah, Oscar. Good job, guys. Good job. Very good, very good. Yeah, great. So it all starts by computing the derivative of this function, right? In this case is cosine. We know that the derivative of cosine is just negative sine, right? Tricky one. But now this is telling me that the slope of the tangent line at any input value x is just given by minus sine of x. Now, I don't want the slope line at any value of x. I want the slope line at this value of x, right? Pi over 2. So if you substitute that value at x equal pi over 2, which is this, right? Comes from there. Then you will see that the slope of your tangent line is going to be as this. The slope of the tangent line will be negative sine of pi over 2, right? What is negative sine of pi over 2? Well, if you want to do it using the unit circle, you need the coordinates of this point in the unit circle, right? In the unit circle for pi over 2, this is 0, 1. And remember that in the unit circle, the second coordinate is sine, right? The second coordinate. So we're going to look at the second coordinate. This should be 1, and this should be -1, right? And that is using the unit circle, right? Sarah. Excellent, excellent, right? Yeah, that's it. Yeah, but let's say you forgot the unit circle, you just want to get this done. If you want to use the calculator, you can use the calculator, guys, but just be careful, right? Remember, make sure you're working in radians. So when I use the calculator and compute it just to confirm. So what is minus sine? Minus sine of pi over 2, pi is here, divided by 2. Look, it's not giving me -1, it's giving me some decimal number, but this is when you work in degrees. But as long as you work in radians, it should be the same. In radians, -1, right? Yeah, so one more note here. Note. Make sure you set your calculator to work in radians. And this is something that is going to help you even in calculus 2 to work in radians. Calculus 1, calculus 2, mathematicians work in radians. Very rare if they work in degrees, right? Yeah, radians. All right, so -1. This is the slope, right? Of the tangent line. But now, together with this slope of the tangent line, we have this extra information. We have a point. The point is given by this guy, pi over 2, right? But we need the partner of pi over 2. It's not given, not a problem, because we have the function. The function is cosine of x. So cosine of pi over 2 should be the partner of pi over 2 via the function, right? But what is cosine of pi over 2, Professor? Well, here in the unit circle, you pay attention to the first coordinate. That's always cosine, right? Cosine 0, right? Okay. Now, if you want to use the calculator and compute cosine of pi over 2, you can always do that. But just make sure that you're working in radians, guys. Just make sure that your calculator is working in radians, because otherwise it's not going to give you the right rise in degrees. But make sure you're working in radians. 0, right? There you go. Now, simply use any method you know to compute the equation of a line when you have the slope and the coordinates of one point. I'm using this point slope form. Call this x1, this y1, substituting, this will be y minus y1 is 0, equal slope is -1, multiplying x minus x1 is pi over 2. 0 disappears from the scene, y equal -1 times x minus x, -1 times minus pi, minus and minus plus pi over 2, right? And believe it or not, guys, this is it. This is the equation of the tangent line of the graph of y equal cosine at x equal pi over 2. Now let's talk about the derivative of the tangent function. So far, we know that the derivative of sine of x is equal to cosine of x, right? We have memorized this. Derivative of cosine of x is equal to minus sine of x, right? We have this, we know this by heart now, these two results. But what about derivative of the function f of x equal tangent of x, Well, for that, I'm gonna help myself out by recalling from trigonometry that you might have seen in pre-calculus, right? There is this so-called quotient identity. Tangent of x is equal to sine of x over cosine of x, right? Over cosine. It's called quotient identity. Tangent, sine over cosine. But now, then, using this quotient form, I can take the derivative of tangent by following the quotient rule, right? The quotient rule. Remember the quotient rule that we saw yesterday? We can use that now, the quotient rule. So I'm gonna take the derivative with respect to x of sine of x over cosine of x, okay? Which is tangent, right? Now this guy, sine of x, will play the role of f, and this guy, cosine of x, will play the role of g, my g function, right? And let's just recall our quotient identity, or the quotient rule, better said, right? Recall quotient rule that you should memorize too. We're going to use it a lot. F divided by g, when you take the derivative of this, that's equal to derivative of the numerator times the denominator g minus derivative of g times f all over g squared. And comment here if in case on the textbook or somewhere else you see this guy first, this guy following, this guy first, this guy following. Doesn't matter because multiplication is commutative, right? So it still works. I just try to get the derivatives first. Okay, so recalling this on the side, then we can say that this derivative is supposed to be equal to what? Well, this will be equal to what? Derivative of the function f, derivative of sine is just cosine of x, right? Times the other function as it is cosine of x, right? And multiply there, minus derivative of the g function, derivative of cosine. That is equal to minus sine of x, right? Minus sine of x. Multiply by the function f as it is. Function f as it is sine of x, right? Sine of x. All over the function g, which is cosine is squared, right? Cosine of x, all that is squared. But now simplifying, cosine times cosine is cosine squared, right? Cosine squared. But that cosine squared, mathematicians write it as like this: cosine is square of x, right? Somehow they put this exponent in the middle here, up here, right? Cosine square of x. This is this. Minus and minus plus, right? Sine of x times sine of x is going to be sine of x squared. But that mathematicians write as sine square of x, right? This is a numerator. Denominator, I'm going to just put the 2 in the middle here, cosine square of x. But now, anyone in the chat could tell me what is this equal to, this cosine square plus sine square, according to the identities that you learned in pre-calculus. It's called the Pythagorean identity. What is sine square plus cosine square? Or equivalently, right? Cosine square plus sine square. Aha, I see students are remembering that. This has a value, yeah. Sarah, yeah, you went by the Adriana also, very good. Excellent, excellent. It's just one, right? It's just one. It's called the Pythagorean identity. It's just one. Okay, great. One here, right? One. And this cosine square on the bottom, right? Cosine square on the bottom. Great. But now, one more question, right? What is this? Recall. What is 1 over cosine of x using the reciprocal identities, right? What is this equal to? Anybody remembers? Remember, I can give you as a hint. 1 over sine is cosecant, but what is 1 over cosine? What is that equal to as a trigonometric function? Remember 1 over sine, secant, cosecant, sorry. 1 over cosine should be just, Adriana, yeah, excellent. Cosecant is 1 over sine, 1 over cosine, secant, right? Excellent, excellent. Secant. Yeah, this is this, right? 1 over cosine. But here I have this is squared, right? So, but what? Not hard to see that if you square this side and you square the other side, you will get that this square should be equal to this square, right? So bottom line, 1 square is 1. Cosine square is cosine square of x should be equal to this secant square of x. So believe it or not, guys, this is equal to secant square of x, which is the next result that we should remember. In the end, I will give you a table, okay? So this derivative of tangent is equal to secant square of x, right? This is the other result that you should really memorize, okay? The derivative of tangent of x equals secant square of x. Okay, we show this using that quotient rule, right? So similarly, mathematicians play around with cotangent being equal to cosine over sine, right? They did the whole quotient rule with cosine over sine, and they show that the derivative of cotangent similarly is equal to minus cosecant square of x. Okay, this minus is not a typo, guys. It's there because you are dealing now with cotangent, right? Not with tangent. Derivative of tangent secant square, derivative of cotangent cosecant square, negative with a negative sign up front. Similarly, mathematicians use for secant 1 over cosine, right? Like in here, 1 over cosine. If you apply the quotient rule to this, then you get that the derivative of secant of x is surprisingly this, like secant of x times tangent of x. Start with itself, but then gets multiplied by tangent when you simplify. So this is the other result that you should remember. And finally, mathematicians have shown that the derivative of cosecant of x is equal to minus cosecant of x multiplied by cotangent of x, okay? That's the last result. So 6 results that we should remember, okay? But in case you want to make sure, double check, confirm your results, here is a sheet with all the results. I'm gonna give you the link right now. This is in our website, also in Blackboard, right? If you go to course materials and you go to the tab, I think it's useful links, not useful link, useful sheets, okay? Derivative of sine equal cosine, derivative of cosine equal minus sine, derivative of tangent equal secant squared, derivative of cotangent minus cosecant squared, derivative of secant times tangent, derivative of cosecant minus cosecant times cotangent. I'm gonna give you the link, the straight link, in case you want to just bookmark it or you want to save it in your computer. Is this, right? Yeah, but it's also in our website and in our Blackboard account, okay? It's there. You click in there, you will have access to it. All right, have it handy, print it out in case you have a hard time memorizing these 6 results. And then you can look at them at any moment, especially when you're taking your examinations, right? Very good. So using these 6 results, right, we can do more now, right? We can take derivatives of these types of expressions, for example, right? So let me show you this example. What if they ask you to take the derivative of this expression, x squared minus 2 times tangent of x? Well, start by distributing your derivative over this difference. Remember, derivatives, they behave very nicely over a sum, over a difference of functions, right? So we just distribute. Derivative with respect to x of twice tangent of x. Next, the derivative of this part should be equal to what? Anyone could say on the chat? Derivative of x squared. Yeah. Using the power rule, Sarah, excellent, right? Twice x, right? Twice x. Very good, guys. Twice x, right? And what should be the derivative of this part? Knowing that the number 2 comes out and this derivative of tangent, we just explained, right? We have that is secant squared, right? Secant squared. But in case difficulties memorizing that is here, secant squared. So this will be, very good, 2 times secant squared, right? Excellent, excellent, very good, very good. 2 times secant squared. Let's close this. 2 times secant squared. All right, very good. And that's it, right? This is the answer. Very good. Moving on, another example here. Let's check that out. It says take the derivative of x times secant of x, the product of two functions, right? The product of two functions. So quickly you identify the first factor as f, the second factor as g, right? It's a product of two functions. So recall your product rule says that the derivative of f times g is equal to derivative of f multiplied by g plus derivative of g multiplied by f, right? So this should be equal to the derivative of f. Start with that. Derivative of this guy x, since it's just the identity function, right? This is equal to just 1, right? 1. Excellent, excellent. 1. 1 times the second function as it is secant of x, right? Secant of x plus the derivative of the g function, the derivative of secant of x. What is the derivative of secant of x? Anyone could write on the chat. Derivative of secant of x. Respect to x. Here, the table for you to identify. Yeah, excellent, excellent, Adriana. Secant times tangent, Oscar also, right? Very good, Sarah. Very good, guys, very good, right? Yeah, it's here, right? Derivative of secant times tangent, right? Yeah, great, excellent. So this is what you write, secant times tangent, but notice that this secant times tangent is just the derivative of the g function. It still must be multiplied by the derivative, not the derivative, the function f as it is, right? Which is the identity function. Don't forget about this x. All right, then finally, just simplify. 1 times secant of x is secant of x, plus here, follow the agreement. Simple functions up front, complicated ones follow. Right? That is how mathematicians present the final answers, right? Often follow that. All right, that's it. Okay, I have here more examples, but I want you to try some exercises on your own, and then we're gonna go with these tricky ones. So let's go back here. And I think at the very beginning, I saw good exercise here. Can you try? Yeah, this one requires the trick. Let's start with this one, number 5. Then we'll go over other ones. Can you find the derivative of this function? Derivative of the function s with respect to t. What will be this? Derivative of t to the 7 minus cosecant of t plus 2 with respect to t. Hint, distribute your derivative over this difference over this sum, right? And figure it out. And then for the derivative of cosecant is cosecant times cotangent negative, right? Negative, so you gotta use this. Yeah. Maybe. Yeah. Try to figure this out, yeah. Yeah, use this. Yeah, maybe you can see. Yeah, great. The choices. Ah, I see students posting. Oscar, yeah, very good. Excellent, excellent. Yeah, very good. You got it. Yeah, so, Sarah, also great. Very good, guys. Sarah, Oscar, very good, very good. So, let's do it together, right? This is saying, okay, this should be equal to, let's write it down here, better, to what? Well, derivative of this guy, 7 raised, t raised to 7. That is 7 t raised to 1 less stays here, right? 6. Done. Minus, minus. Derivative of this guy, derivative of cosecant. We just saw that is negative cosecant times cotangent, right? Negative cosecant times cotangent. Don't forget about that negative. So I'm going to write between parentheses negative cosecant of t times cotangent of t. This is the derivative of this guy, plus. Derivative of the constant function 2 is just 0, right? 0, nothing. So now simplifying this, 7t to the 6 here, minus and minus, plus, right? Plus cosecant of t multiplied by cotangent of t, right? This is it. This should be the answer, and this is a perfect match with choice A, right? Choice A. Very good. Excellent, excellent, guys. Very good. Very good. All right, so that was one. Let's go over this one now. The first one, I hope you will be able to handle this a little bit tricky. I will give you the hint. Can you try this now? Y equal, rewrite this 8 over x as 8 multiplying x raised to minus 1 plus 6 multiplied by secant of x, right? Figure out the derivative of y with respect to x, right? Which is going to be the derivative of this guy with respect to x, okay? So try to see if you can handle this. Last hint, distribute your derivative over, right? Because remember, derivatives, they behave very nicely over sums, right? In the sense that you can distribute always your derivative over sums. Do that and figure out the answer, right? In the end, if you end up with negative exponents, then you should change your expression algebraically so that it shows just positive exponents, right? Let's try to do this. I see students posting answers. Yeah, always give it a shot, guys. You don't have to be right all the time. We're learning here together. Oscar, excellent. Good work, good work. Excellent, excellent. Yeah. Yeah, very good, very good, very good. Yeah, very good, very good. More students are trying. Adriana, excellent, excellent. Very good, very good. Excellent, excellent. Yeah, very good. Let's do it together so we can go over more forms. You're supposed to take the derivative of this guy, right? But the derivative of this guy is what? 8 is a constant, comes outside, and the derivative of this x raised to minus 1 should be minus 1 up front, x raised to minus 1, right? We'll deal with that. Plus. Derivative of this part. Derivative of this part, I have a constant. I take the constant outside of the differentiation, and the derivative of secant, remember, is secant multiplied by tangent. Professor, how do you know? Well, I have them, I know them by heart, but in case you need to check here, derivative of secant of x times tangent of x, I gave you the link of this sheet. It's also in our website in black, right? Good. All right, but now there's this issue, right? When you simplify, this is negative 8x raised to minus 1 is minus 2 plus 6. secant of x multiplied by tangent of x. So I don't see this here, especially this part is not there. Remember, mathematicians don't like to see negative exponents as part of final answers, right? So the way you deal with that is this. Put this down here as 1 over x squared. So you will have negative 8 times 1 over x squared plus 6 multiplying secant of x multiplying tangent of x, right? Now, negative 8 times 1 is just negative 8. That negative, mathematicians place it here in the middle, right? So this is this. Plus 6 secant of x tangent of x. Look back, and you will see that now it appears there is this guy, right? Follow, guys? Y prime, this is prime, right? If you don't see the prime for the derivative, is this the derivative? Very good, this is this. Yeah, excellent. Now, before we move to the tricky ones, probably you should try this one with product rule number 2. And then I will show you how to do these ones that are tricky. Number 2, can you figure out the derivative of this function, derivative of s with respect to t, derivative of t to the 5th power multiplied by tangent of t minus a square root of t. This with respect to t. Hint here, first hint, use product rule for this part, right? For this part, let this be f, let this be, once you distribute your derivative, you will have to use product rule for this part. Second hint, the derivative of this guy, when you distribute the derivative of the difference, we wrote that out. So first hint, use product rule, right? Product rule, which is this. Derivative of this is f prime g plus g prime f multiplied, right? And the second hint is derivative with respect to t of, well, let's write with respect to x in general, right? Of a square root of x. Remember, we got this as 1 over 2 a square root of x, right? All simplified. So use this result too for this part. 1 over 2 times the square root of x. And they use the product rule and figure out what should be the answer there. And then we'll move to other forms, guys. Yeah, probably I should write this as a hint too, right? That this is gonna be the derivative of this part, tangent of t minus derivative with respect to t of this guy, right? Yeah, this is what you're gonna follow. Because you know that derivatives can be distributed over sums over differences, right? Yeah, so to get this done. Continue there. And if you need the sheet with formulas here, looking for derivative of tangent, right? So this guy's here. Here, there. Let's make this smaller. Ah, I see students already posting. Yeah, in case you need this, there. Yeah, it's there. Let's see, number 2. Oscar. Excellent. Yeah, very good, very good. Yeah, it's a little bit tedious, algebraically speaking, but if you know the formulas, again, I strongly recommend you to have this printed out, put it in your wall or somewhere where you can see the formulas right quickly. Grace, very good too. Very good. Excellent, excellent. Very good, Grace. Yeah, following this formula, you should be fine. Great, right? Derivative of tangent secant square, right? Let's just recall that. Okay, so let's do it together. So here, product rule, right? Product rule. This is the f function. This is the g function, right? So we're gonna do product rule here. Start with the derivative of f. F prime is gonna be 5t raised to the 4th power, right? But this guy has to be multiplied by the function g as it is tangent of t, plus the derivative of tangent, derivative of g now, right? According to the product rule here, is derivative of tangent, which is secant squared, right? Secant square of t, that multiplied by this other function as it is, t to the 5th power. Yeah, this is just the result of applying the product rule to this part here, but then this has to be followed by minus derivative of this guy. But we said the derivative of this guy, we work it out completely, is 1 over twice square root of t, because t is the variable now, right? T. All right, then just simplify. Remember, follow this mathematical agreement, the simple functions first, followed by the complicated ones here. Simple function t to the 5th power, followed by complicated function secant square of t, and this minus 1 over 2 the square root of t. And if you look through, guys, this is here, right? They have written this term second, this term next, but remember the ordering of the addends does not change the sum. So this is the same as this, right? As long as these 3 terms are there with their signs, this is the one that you have to choose. Be careful. All right, guys, this is there, and this is here at the end. Very good, very good. Now, let me show you guys what to do in case they give you something like this. I will show you now. Like this, something like this, right? This 2 over sine plus 1 over cosine. You can go ahead and try to use the quotient rule here, quotient rule again, right? But it's very tedious. It's going to be really, really tedious because you're going to get a couple of fractions. You have to add them with the LCD and simplify. Sometimes it is better to simplify this trigonometrically and then take the derivative. You will see that this will simplify a lot the differentiation. How does it work, Professor? Well, let me give you a couple of examples here. First example is this. And this is going to help you also with your homework, guys. So try to catch the strategy. It says more examples here. Sometimes it is better to simplify first. And when I say simplify, I mean simplify using trigonometric identities. Maybe simplify using trigonometric identities. Okay. Yeah. So first, and then take the derivative, right? So example, suppose they are asking you to find the derivative of this expression, y equal 3 over cosine of x plus 2 over tangent of x. That's the function, right? So as I said, right, instead of going straight and getting using the quotient rule here, try this. Simplify using trigonometric identities. Well, isn't it true that when you study trigonometry, right, they talk to you about these reciprocal identities, right? Reciprocal identities. And there they show you that there is a way to rewrite this expression. I'm going to write this 3 over cosine as 3 times 1 over cosine. They're the same, right? But in trigonometry, we know that there is a way to rewrite this as a one trigonometric function, right? And what is that? Do you remember? What is 1 over cosine in trigonometry? And here the same 1 over tangent using the reciprocal identities. 1 over cosine. I see. See, Adriana, excellent, excellent, right? Secant, right? Secant. And you say, Professor, but what's the big deal of writing this as secant? You will see soon. Now, in trigonometry also, what is 1 over tangent using the trigonometric reciprocal identities? 1 over sine is cosecant, 1 over cosine is secant, 1 over tangent. What is that? Well, remember, tangent and cotangent reciprocals of each other, right? So this 1 over tangent using the trigonometric reciprocal identities is cotangent. Cotangent of x. Professor, but then what have we gained? Well, notice that now I don't have fractions anymore, right? I just have secant and cotangent. And the good news is that I have formulas, direct formulas to deal with the derivative of secant and the derivative of cotangent, right? Look, the derivative of cotangent is minus cosecant. The derivative of secant is secant times tangent, right? So once you simplify, then now take the derivative, right? That's the second step. So taking the derivative now, then you can say that the derivative of y with respect to x will be equal to, once we distribute our derivative over this sum, right? And taking out the constant, it will be 3 times derivative of secant of x with respect to x, which is easy to get, right? Plus 2 times, 2 comes out, derivative of cotangent of x with respect to x, right? So basically in one step, we're gonna get this done. Look, this will be 3 times. Derivative of secant is secant of x multiplied by tangent of x, right? Wow, Professor, you know them by heart, but what if I forget? If you have no problem, guys, it's here. Derivative of secant multiplied by tangent, right? That's what I wrote here. And derivative of cotangent minus cosecant squared, right? Is here. Minus cosecant squared, right? Just write it down. So plus, but this is minus plus 2 multiplied minus cosecant square of x, right? So bottom line, this should be just equal to the following. Let's write it once and for all. It should be just equal to the following. Plus here twice. Twice. Twice minus cosecant square of x, which tells us that the derivative of y with respect to x is equal to 3 secant of x multiplied by tangent of x minus, plus or minus 2 cosecant square of x, right? Cosecant square of x. And this is it. This will be the final answer, right? You follow, guys? So this is a tricky one. This is example 2. But before I go example 2, I want you to practice on this. So let's go back here. Now then you can do this, right? There was one where we're putting on hold somewhere. This. Can you try this? There are 2 here. Try this one the first. So let's demystify this, guys. If you encounter this form in your homework, you know what to do, right? It can be done also using, I think, quotient rule, but it's more difficult. Try to keep it simple. Simplify first. Yeah. Step 1. Simplify first. using trigonometry identities. And step 2, take derivative, right? Take derivative. Using your knowledge of the derivative of trigonometric function, or by looking at this sheet here, right? Mm-hmm. Mm-hmm. Yeah. Yeah, using trigonometric identities, right? Yeah. Uh-huh. I see students posting answer. Adriana, very good. Grace, very good. Excellent. Number 3. Double check. Excellent, excellent, guys. Very good, very good. Yeah, Adriana, Grace, excellent work. Oscar, very good, guys. So basically, we simplify first, right? We say y is equal to what? This is like 1 over sine, right? 1 over sine. So 1 over sine is cosecant, right? Cosecant of x for this part. Plus, this is 1 over cotangent, but 1 over cotangent we said in trigonometry is tangent, right? Tangent. So we simplify using trigonometric identities. Now take the derivative. If you take the derivative, y prime, and using sort of on purpose this other notation, the prime notation will be the derivative of this part plus the derivative of this part, right? Yeah. All right. So what's the derivative of this part? Well, the derivative of this part should be just 2 outside derivative of cosecant. But the derivative of cosecant is minus cosecant of x multiplied by cotangent of x, right? And the derivative of tangent is minus, not minus, secant square, right? Secant square. Professor, what if I don't remember this? No problem, guys, it's there. I send you a link, it's on our website, right? Derivative of cosecant is here, minus cosecant times cotangent, and derivative of tangent is here, secant square. Print out the sheet, right? I give you the link. So this will be minus 2 cosecant of x multiplied by cotangent of x, simplifying, right? Plus secant square of x. All right, so looking through for number 3, you can clearly see this here, right? There you go. Y prime equal this. Excellent. This one, you can do it at home, is similar, right? To the home, but now let me show you how to do this other one. It's another one here that this requires a trick, this type of things, this type of this form. So let me give you an example, and then we'll go back there. Second example for this strategy. Suppose they ask you to find the derivative of secant of x minus cosecant of x over secant of x. If you try to do it in a straightforward way, you may think of the quotient rule, but imagine taking the derivative here, multiply, it's gonna be very long, right, and difficult. Instead, let's use our other strategy. It says first, simplify using trigonometric identities. So what I'm gonna do there is, I'm gonna see if I can simplify this using trigonometric identities that we learned in pre-calculus, right? Y equal secant of x minus cosecant of x here, all divided by this guy, right? But what if we do this? We divide this guy into this guy this way, and this secant into cosecant. This is 1, right? 1. And it's good one, the constant function is easy to differentiate, right? So this is good for us. Minus this part. This part, this is secant. So yeah, secant, right? This, you mean this? Yeah, here, right? Yeah, thank you. This is secant, right? Yeah, secant. You mean that? Yeah, great. Very good, guys. Now, this is going to be 1 over sine of x, right? And this 1 over cosine of x. Yeah, and then this will become 1 minus, remember when you divide by a fraction, you end up multiplying by the reciprocal, right? So it will be 1 over sine of x times cosine of x over 1. Professor, all this madness, will it be useful? Yeah, you will see. Now look, cosine of x times 1, cosine of x. 1 times sine of x, right? But notice that then this is 1 minus cosine of x divided by sine of x in trigonometry using the Cauchy identity is just cotangent of x, right? Cotangent of x. Look, this complicated form, I was able to reduce it to this simpler form, right? To differentiate, to take derivatives, right? Because now, second, it says, right, take derivative. When you take the derivative, notice the derivative of y with respect to x will be just equal to the derivative of this part, a constant function with respect to x, minus the derivative of cotangent of x, right? Which I know what it is, right? So this guy, 0 minus this guy, derivative of cotangent is minus cosecant square of x, right? Professor, what if I need to check that? No problem, guys. Derivative of cotangent minus cosecant square is there, right? And in the end, you just do the algebra here. This is equal to 0, disappears, minus and minus plus, so minus cosecant square of x. That's it, right? You see, when you simplify, then you end up with a simpler form to differentiate, right? Derivative is 0, derivative of cotangent is just this. Otherwise, will be probably a little bit difficult to get this done. All right, let me go to the worksheet then, and let's practice on this form, okay? So when you do your homework, when you take your exams, you will not be surprised. Try this, guys. 8. Yeah, great. Very good, guys. So you are supposed to take the derivative of P with respect to Q, right? But first, first simplify, right? You can follow what I did before. First, simplify. Meaning divide this cosecant of Q into these two, right? Separately. So cosecant of Q. Right? Divide this into this into this. First, simplify first. Once you simplify, second, take the derivative. Take derivative. Right? Can you try this one? Probably we will need space for this part. So I'm going to leave some space here. Yeah, let me second take derivative, right? Second, this part should be easy. Second, take derivative. Derivative. Yeah, first simplify and then take derivative, right? When I say simplify, I mean you have to do this, right? Divide this by this plus cosecant of Q over cosecant of q. And this will be just 1. Right? Yeah. Simplify and then, you know, detect the derivative. Using this sheet, right? Mm-hmm. Remember, secant 1 over cosine, cosecant 1 over sine. Very good, guys. So, yeah, Adriana, very good, excellent. Yeah, good job. Yeah, very good. Yeah, let's do it together so we can take the second break. All right, so here for this part, this is 1 over cosine of q. This is 1 over sine of q plus cosecant of q divided by cosecant of q, or cosecant of q into cosecant of q is just 1. Remember, when you divide by a fraction, you end up multiplying by the reciprocal of this fraction on the denominator, right? Here 1. But this leads to sine of q over cosine of q, which is just tangent of q plus 1, right? So now take the derivative, right? Take the derivative with respect to q, of this guy, right? Tangent of q plus 1. But the derivative of tangent of q is secant square of q, right? And the derivative of the constant function 1 is just 0 plus 0, right? So this, believe it or not, guys, ends up being just secant square of q, which is here. Excellent, guys. Should be. Yeah, very good. So now probably we should take our second break, right? And then we will continue with the last part, which deals with higher order derivatives, okay? Higher order derivatives. What's that, Professor? Well, it's first derivative, second derivative, third derivative, fourth derivative, and so on. I will explain that nicely, but now let's take our second break, okay? So second break. We're gonna go from 7:56 to 8:06. All right. Okay. And we will go over higher order derivatives. As usual, guys, if you want to take a break, feel free to do so, or get a cup of coffee, cup of tea, water, or you can ask me questions related to homework problems or to Maple Labs, or perhaps to the review for the exam number 1 that is already out there. You might have encountered this trigonometric stuff there, so little by little you will get more knowledge to go over the entire review. Tomorrow we will do chain rule, right? So then with that we will complete all the topics for you to take your exam 1. So any questions, let me know, or any comments. Now let's continue, right? Let's go over this exercise. Can you try this? Now we know how to take derivative of cotangent, right? It's here. So using that, try to figure out the equation of the tangent line that corresponds to the graph of this function y equal cotangent of x. Use this, right? Derivative of cotangent minus cosecant of x, and then figure out the equation of the tangent line, right? Yeah. I'm gonna give you a hint here. Start with the derivative of cotangent, right? Tangent of x. And that we know that is equal to minus cosecant square of x, right? And then this is gonna be the slope of your tangent line, right? And then calculate this somehow using 1 over sine, perhaps, at x equal this guy, pi over 4, right? Pi over 4. And that will be your slope, right? Your slope, your tangent line will be this minus cosecant of pi over 4. And that you can get it in the calculator, right? Or you can get it in exact form. We will see how this goes, because I can see that they probably use there the exact form. Yeah, but we will figure this out together. And don't forget the square, right? Yeah, don't forget the square. So you can compute this in the scientific calculator. In the scientific calculator, try to use 1 over sine, right? 1 over sine of this is square, right? Square. Yeah. Let's do it together, right? It's very tricky. So let's do it together. And notice that this this has to be calculated somehow in the calculator. Okay, so let's do it together. So if you bring out your scientific calculator or the decimal scientific calculator, what is this guy? Remember, cosecant is not here. There is a sine, cosine, and tangent. So this guy must be computed as 1 over sine squared, right? So let's write it here. The way you will compute this in your scientific calculator is this: minus 1 over sine of pi over 4, right, is squared, right, is squared. This is the way. 1 over sine. So 1 over sine is cosecant, right? Yeah, so if you do this in your calculator, you're gonna have the following. It's a negative sine of psi, then parentheses, 1 over sine function sine of this guy, pi over 4, right? Carefully come out of there, and this as a parenthesis, and raise this whole thing to the second power. 1 over sine of pi over 4, you can see, right? Raised to the second power. This is this. Now, remember, this is in degrees, but we want these results in radians. So go to radians, minus 2, right? Minus 2. That is it, minus 2. Right? Minus 2, this guy. The slope, minus 2. Okay, with that slope, with a slope equal minus 2, and point is going to be this, pi over 4 x coordinate, right? And what is the y coordinate? We don't have it, but we have the functions. So the y coordinate will be cotangent of pi over 4. And I think this is what Sarah was asking, right? How I compute cotangent of pi over 4? Well, this is 1 over tangent, right? 1 over tangent of pi over 4. And that 1 over tangent, since tangent is just 1, sorry. Since tangent is just 1, it will be just 1, right? So pi over 4, comma 1. Point pi over 4. This guy is just 1. Here in the calculator, 1 over tangent of pi over 4. That's just in degrees, but we want it in radians, 1, right? 1 over 1, 1. Very good. So this is the point, this is the slope. So we use our point slope form. This is x1, this is y1. Y minus y1, which is 1, equal slope, negative 2, multiplying x minus x1 pi over 4, right? Pi over 4. Very close to the end. Y minus 1 equal minus 2x minus 2 times minus pi over 4, minus and minus plus 2 pi over 4, simplifying, this is y minus 1 equal minus 2x plus pi over 2, right? Halves and halves. And adding 1 to both sides, I think we should get it. Plus 1 here. Y equal, after you cancel these two guys, y equal negative 2x plus pi over 2 plus 1. Leave it alone, guys. Remember, I explained, right? Mathematicians prefer to see this in exact form. So look for it. I think it's here. See, a very tricky question, right? Yeah, for 11. Very good. With this, guys, let's move on to the last part, which deals with higher order derivative, taking again and again and again, second derivative, third derivative, and so on, right? Fourth derivative, stuff like that. So let's take a look at that. Higher order derivatives is here. Okay, since the derivative of a function is itself a function, right? Y equal f prime of x, we can take the derivative of the new function f prime of x, which is generally called the second derivative, right? So the derivative of the derivative is called the second derivative of f of x. Also written as f double prime of x, or f with a number 2 on the top of x, right? So this differentiable process can be continued, right? To find the third derivative, fourth derivative, and successive derivative, right? If you take the derivative of the second derivative, then you get the third derivative. The derivative of the third derivative will be the fourth derivative, right? And so on, right? And these successive derivatives are called higher order derivatives of f of x. Here is an example, a nice example. Suppose they ask you to find the first, the second, and the third derivatives of this polynomial function, f of x equal 5x cubed minus 2x squared plus x minus 6. They want you to get first derivative, second derivative, and third derivative. How you proceed? Well, start with the first derivative, right? Start with the first derivative, f prime. We know how to get this guy, right? F prime, x. That should be the derivative of this guy, which is going to be 3 coming down multiplying 5, 15, x squared, right? Minus 2 coming down multiplying 2, 4, x, right? Plus derivative of identity function, which is 1, minus derivative of 6, which is 0, right? So this is the first derivative. First derivative was computed here. Now let's go ahead and take the second derivative. The second derivative is going to be the derivative of the first derivative, right? Of this polynomial now, right? So you take the derivative again for the second derivative. Derivative of this term, 2 comes down, multiply 15 is 30, x. Derivative of this part minus 4 is the constant. Derivative of x is just 1, 4, derivative 1, 0, right? 0. So there you see the second derivative, right? They want the third derivative, f triple prime, right? It was f double prime. Triple prime. Derivative of the second derivative will be derivative of 30x, 30 constant outside, derivative of x, identity function 1, just 30, right? Derivative of 4 is 0. So there you go. Third derivative is 30. Here are the 3 derivatives associated to this function. First derivative, second derivative, third derivative. All right. Now, notation. Mathematicians use the following notation to specify these derivatives. For the first derivative, y prime, f prime of x, we know that, right? Or f with a number 1 on the top in the middle here of x, or this derivative of f of x with respect to x, or capital D, y here and x here. derivative of y with respect to x, right? This is for the first derivative. We already know this, right? But how you represent the second derivative using this notation now? Well, y double prime, f double prime of x, f with a number 2 here in the middle up here of x, second derivative of f of x with respect to x. You place the number 2 on the top here and also number 2 on the bottom here to identify that you are dealing with a second derivative, right? Or if you use the capital D, don't forget to put a 2 on the top here, y here, x here. Similarly, the third derivative should be y triple prime, f triple prime of x, f with the number 3 on the top of x, or derivative of f of x with respect to x, writing this 3 on the top here, 3 on the top here to identify that you're dealing with the third derivative, right? Or if you use the capital D, big D here, 3 on the top, y here, x here. The third derivative of y with respect to x. That means that similarly you continue, right? But the thing is, you know, this representation is not so convenient, right? Because imagine if you are taking the 15 derivative, you don't want to write 15 of this, right? Perhaps you should just use this notation then, right? Just write 15 on the top here, or here 15, here 15, right? Sometimes this notation may not be useful. But fortunately, we will go up to third derivative, fourth derivative, perhaps not farther than that. So here is an example. Suppose they ask you to compute the third derivative of this function, x times cosine of x, x times cosine of x. We're going to do it slowly and nicely, right? So you can see how this should be done. First derivative, then we start with this, right? Derivative of x times cosine of x with respect to x, right? What is this derivative? Well, notice I have a multiplication of functions here. So I have to use my product rule, right? We have to use our product rule. So we have to take the derivative of this guy. When I recall here, product rule says derivative of f times g equal f prime times g plus g prime times f, right? So let's do that. Derivative of x first, derivative of this guy first. This is f, this is g, right? Derivative of this guy first. Derivative of identity function x is just 1, right? 1, just write 1 here, times the other function g as it is, cosine of x, plus derivative of g, derivative of cosine, remember guys, is minus sine, right? Minus sine of x, times the derivative, not the derivative, the function f as it is, x, right? X. So this is the first derivative, right? The first derivative. And that is equal to cosine of x minus, let's follow the agreement, simple functions up front, complicated ones following. So sine there. Very good. This is the first derivative, right? Now, but I'm not done because I still have to compute the second derivative now. So for the second derivative, I gotta go up to the third derivative, right? So for the second derivative, I have to take that derivative of the first derivative, right? Yeah, which is gonna be this. I gotta deal with the derivative of this now, right? This. So it's gonna be the derivative with respect to x of this guy. Derivative of the derivative. All right. So now for this, after I distribute my derivatives over this difference, the derivative of cosine of x is minus sine of x, right? Minus here, minus derivative of this. But then here again, there's a product of two functions, right? F times g. So I gotta use the product rule again. Derivative of f times g f prime times g plus g prime times f, right? For this part. Start with the derivative of f, derivative for identity function is 1. Multiply that by the function g as it is, sine of x, plus derivative of g, derivative of sine is cosine of x, multiply by function f as it is times x, right? And look, allow me to put this inside this big parenthesis. Carefully do this, guys, if you are not used to taking higher order derivatives. Minus sine of x here, minus distributed over gives me minus sine of x, minus, when you distribute, will be minus x. I'm gonna write this up front, this guy following cosine of x, right? Minus. Now, combine these two like terms, minus 1 sine of x minus 1 sine of x is minus 2 sine of x, right? Combine, minus 2 sine of x, this is this, minus x cosine of x, right? Minus x cosine of x. Very good, guys, very good. Excellent. So I successfully computed the second derivative, right? But they want the third derivative. So I gotta do this one more time. So third derivative of x cosine of x with respect to x should be the derivative of the second derivative now, right? The derivative of this guy. So let's do that. Derivative with respect to x of minus 2 sine of x minus x cosine of x. Let's do this carefully. Distribute your derivative over, right? And you will see that here for this first term, minus 2 is a constant, comes out as a constant, and the derivative of sine of x is simply cosine of x, right? Cosine of x. So we are done with this part. There's a minus here. Now derivative of this part, but this part is a product of two functions, the identity function multiplying cosine function, right? So this will play the role of f, this will play the role of g. So we gotta apply our product rule. Product rule says derivative of f times g is f prime times g plus g prime times f, right? Okay, so derivative of f, derivative of identity function is 1 times the function g as it is cosine of x, plus the derivative of the g function, derivative of cosine is minus sine of x, right? Times the derivative of this guy, identity function 1. Not derivative, the function as it is, right? As it is, let's be careful here. So just x. And then close parentheses. Now, carefully get this done. Minus 2 cosine of x minus, when distributed here, will give you minus cosine of x, okay? And minus distributed here, minus, and minus here, plus. Let's write the simple function up front, x, the complicated one following, x sine of x, right? Good. Finally, combine these two like terms. There is an invisible one here, remember? So this means that this can be combined into minus 2 cosine of x minus 1 cosine of x is equal to minus 3 cosine of x, right? Plus x sine of x, which should be my third derivative, right? My third derivative. This is the worst this could get, guys. It's not going to go farther than the third derivative at this level, okay? So this will be the most complicated you should expect an exercise to be. Okay, so this is how you take first, second, and third derivative, right? Now I want you to practice. I want you to practice a lot here. Let's start with something simple, and then we will get to the complicated ones. So what about starting with this first? Can you do this? And then we'll go over the product rule. Yeah, this doesn't require product rule, so should be doable. find the second derivative, right? And your function is this, it starts with this. Yeah, can you try this, right? You're supposed to compute the derivative first. And once you're done, you go ahead and take the derivative of the derivative and you get the second derivative. Or maybe I should show you this one and then you can do number 3. Let me explain this to you, okay? And then you will do this one similar. All right, when they give you this form, it's not that complicated because this is a constant. The constant comes out. First derivative will be minus 4. Derivative of cosine is minus sine of x, right? So this is telling me that the first derivative is 4 times sine of x. And for the second derivative, which is required here, right? Which is asked here, should be just the derivative of this. I see someone figure this out. CG, very good, very good. Excellent. So this game tells me that the second derivative should be just this, right? 4 derivative of this guy, right? 4 sine of x with respect to x, right? The derivative of the derivative. So derivative y double prime, second derivative, better said, is 4 there times the derivative of sine, which is cosine, right? Cosine. Very good, very good. I see more students here posting. Yeah, Grace, excellent. You made my day, Grace. Very good, right? Yeah, so this is not that difficult because it's not really a product rule, it's just a constant multiply. So therefore, this is it, right? Can you try this, number 3, guys? Similar, so follow the previous. Find the second derivative, right? The function start with this. Take the derivative and then take the derivative of the derivative. I see activity on the chat room. CG, very good. Yeah, Sarah also, great, excellent. Yeah, very good, guys, very good. Yeah, it's not that difficult once you follow the rule. Grace, also very good, excellent. All right. Yep. Yeah, let's do it together. The first derivative would be once you take the constant 4 out and you focus on this derivative, the derivative of sine is just cosine, right? Cosine of x. We explain that. All right, that's the first derivative. But now they want the second derivative. Second derivative will be the derivative of the derivative. So we got to take the derivative with respect to x of the derivative, which is this, right? So we do that. So the second derivative, equivalently y double prime, is equal to this. 4 is a constant, right? Comes out 4. And then we have to take the derivative of this guy, right? Maybe I should write it. Sometimes it's better so nobody gets confused. And that is just equal to, second derivative will be equal to 4 multiplied by the derivative of cosine. But the derivative of cosine is minus sine, right? Minus sine of x. Putting these two together, 4 times minus 1 is just minus 4. Minus 4 sine of x. And this is it. This guy, right? Be careful with the signs. Yeah, great. Now, this one deals with a 4 derivative, but you continue taking derivatives in this fashion, right? So this shouldn't be that difficult. Probably we should look for something different. This one now. Can you try this? Number 5. Deals with taking the third derivative of this polynomial function, right? Professor, how do you know it's third derivative? Look at this number 3, right? Number 3. So this is the function start by taking the first derivative, then take the derivative of the derivative, second derivative, and then take the derivative of the second derivative to get that derivative, the third derivative, right? Yes, go ahead. Yeah, for polynomial functions, shouldn't be difficult, right? Yeah, do this one, guys. See, I see. The students figure this out. Excellent. CG. Very good. Very good, Sarah. Very good, Grace. Yeah, good job, guys. Very good, very good. Yeah, for polynomial functions, it shouldn't be that difficult because the first derivative is just the derivative of this term. 3 coming down, multiplying 3, which is a constant that we took out, is just 9x squared, right? One less for the exponent, remember? Plus derivative of this second term. 6 is a constant, comes out, 2 comes down, 2 times 6, 12. X stays with one less as exponent, 1, right? But remember, when the exponent is 1, mathematicians don't write it, right? So just 12x. Now minus the derivative of 4x. The derivative of 4x is equal to what? 4 comes out as a constant. Derivative of identity function x is 1. 4 times 1 is 4, right? 4. Good. Now this is the first derivative, right? First. But they want you to get the third derivative. So let's go now ahead and take the second derivative. Second derivative is going to be the derivative of the derivative, right? The derivative of this function now. 2 comes down, multiplies 9, that is 18. Y raised to 1 less than 2 is 1, but exponent 1, mathematicians don't write it. It's just 18y. Plus. Derivative of this second term, constant is 12, comes outside. Derivative of the identity function 1 is 1. 12 times 1, 12. The derivative of this number 4 is 0. So minus 0, nothing, right? That's the second derivative. But they want the third derivative. So let's go ahead and compute y triple prime. Derivative of this part is going to be 18 constant multiplied by the derivative of y, which is 1. 18 times 1, 18. Plus the derivative of 12, which is 0. Nothing, derivative of constant function. So this is it, right? This is the third derivative, believe it or not, guys. The third derivative is a constant. So it's just this guy. Yeah, that was for number 5. Let's do now one involving multiplication of two functions. Let's see a good one. This was a good one. Yeah, try this one. It's going to be a little bit long, but try to follow what we did right in our example. Yeah, it's a little bit long, but try to follow what we did in our example. Y equal 3x multiplied by sine of x. Hint, treat this as a multiplication of function f3x and function g sine of x. Hint, use product rule. And what's the product rule? Is this, right? The derivative of f times g is f prime times g plus g prime times f. This is the product rule, right? Yeah. Get the first derivative using the product rule, simplify, and once you do that, you go ahead with the second derivative using again the product rule, and then you go ahead with the third derivative. Yeah. And try to remember these steps for your homework, guys. I know it's algebraically tedious, but it's the way it is, right? So let's see. Let's do it together, and then I will ask you to do, I think, number 1, which is simpler, I think. Aha, someone figure it out. Let's see. Yeah, sure, sir. Let me do this, guys, and then I will ask you to do this one. Yeah, the second. Of course. Yeah, I'm here to help you. So let's do it together, okay? Yeah. So first derivative, right? The first derivative will be derivative of f, which is derivative of 3x, which is just 3, right? Taking the constant out, derivative of the identity function 1. So 3. We start with 3. Multiply by g as it is, sine of x, right? Sine of x. Let's put it within parentheses. Plus derivative of g, derivative of sine of x, which is cosine of x, right? Cosine of x within parentheses, times the function f as it is, which is 3x. 3x. This is the first derivative, right? First derivative. Okay, so let's see. The further simplified, right? 3 times sine of x plus, follow this, guys, simple functions like 3x, polynomial functions up front, complicated functions, trigonometric functions following. So this should be it, right? In simplified form, the first derivative. Yeah, very good. Yeah, great. Yeah, we got that, right? So far, so good. Now, for the second derivative, we're going to do this again. We're going to take the derivative of this derivative function now, right? So if we start with the derivative of this guy, that would be 3 times the derivative of sine. But the derivative of sine is just cosine, right? Cosine of x. The difficult part is here because here is a product again, right? So this is f, this is g. Start with the derivative of f, derivative of 3x is just 3, right? Multiply that by cosine, which is the other function as it is, right? Plus derivative of cosine, derivative of g function minus sine of x, right? Times the other function as it is, 3x, right? 3x. Yeah, there we go. Ah, I see. Adriana, yeah, Adriana, I see, figure it out. Number 3. Great, Adriana. Yeah, good. Very good. It's long, but you got it. Yeah, excellent. Yeah, we're headed there. All right. So now here the trick is to simplify first, right? Before going to the third derivative. Look, this is 3 cosine of x. This is plus 3 cosine of x. And this is minus, remember, simple function up front, minus 3x, complicated function, the sine function following there, right? Now, the trick is to notice that these two are like terms, same variable part, right? So we can combine them. 3 cosine plus 3 cosine is equal to 6 cosines, right? 6 cosines. And minus 3x sine of x, right? Yeah. So now we go ahead with the third derivative. The third derivative will be the derivative of the second derivative, right? So one more time, it must be done. Oscar also figured it out. Very good, good, Oscar, good. Yeah, so third derivative will be what? Third derivative will be the derivative of the second derivative, right? The derivative of this guy. The derivative of this part is easy because it's 6 constant out times the derivative of cosine. But the derivative of cosine is minus sine of x, right? Minus sine of x. Here, this minus. Now we're going to deal with the derivative of this guy, but this you got to keep this together, right? So in order to take this derivative, I'm going to write first maybe like this. 3x sine of x, we're going to get the derivative of this, right? Now let's do it nicely. This in order. Minus 6 sine of x here. and here minus, right? This has to stay together. So I'm gonna put a bracket here. Sometimes you can use a big parenthesis too, but in order not to overwhelm myself with so many parentheses, I'm gonna use a bracket to separate the derivative from this negative sign. All right, here use your product rule again, right? F, G. Okay, so derivative of F first, right, is just 3 multiplying the other function as it is G sine of X, right? Sine of X. So 3 multiplied by sine of X plus derivative of sine of X is cosine of X, right? Cosine of X multiplied by the other function as it is 3x, right? 3x here. Huh? Brackets, look, bracket here, negative outside. This is the tricky part. Now, y prime should be equal to what? Minus 6 sine of X, right? Distribute negative sign carefully, minus 3 sine of X minus distributed here minus 3x at front, simple function, cosine following complicated function, right? That's it. And now simplify, right? Simplify if possible. Yeah, I think so, Sarah, but let's double check, okay? Yeah, now these two guys are like terms, right? Yeah, so this is minus 6 sine of X minus 3 sine of X minus 6 minus 3 is minus 9, right? Minus 9, we keep the variable part the same, right? Sine of X, this is how you combine these two like terms. This is different, a different term. These and these are not like terms, right? So just leave this alone. And this, and I see this has to be found here, right? Look, they wrote it backwards. They wrote this guy first for some reason, minus 3 cosine X here. And they wrote this guy later, right? The end. So maybe we should do this. This part is here. And this other part is here. As long as the two parts are there, remember the order of the addends does not change the sum. So as long as the two of them are there, that's the one that you have to choose, right? Very tricky question, guys. Very tricky question. Yeah, so this should be this, right? Yeah, very tricky. Very good, Oscar. Very good, Sarah. Yeah, second sign. The second sign should be negative, Sarah. This because this negative times this, because look at the bracket, is negative, right? Negative. Negative 3 sine of X, negative cosine of 3x multiplied by cosine of X. They are both negative, both signs. Yeah, you can look at this carefully after the lecture is over, right? And then make sure that it's okay. Yeah, but don't be freaked out, guys. For product rule, the worst case scenario will be when they ask you for a third derivative, right? But usually they will ask you just for the second derivative, right? Or if they ask you for the fourth derivative, it will be a function like this. Maybe we should do this for you to know. Or if they ask you for products, second derivative, third derivative, we did the one with third derivative, you can do this at home, right? It's much easier. But let's try this. And if we have time, we can do the first one too. Can you try this? It's easy. Just take derivatives again and again and again. We start with y equal minus 4 cosine of X. Get the first derivative, then the second derivative, then the third derivative, the fourth derivative, right? But it's easy because it's just a constant that you have to take out. Try this problem. Fourth derivative, right? You may say, Professor, how do you know this is the fourth derivative? Because of this number 4, right? Fourth derivative. Maybe I should write here 4 derivative. Because of the number 4, right? We explained that this means 4 derivative. So you have to take the derivative again and again. It's gonna be like eventually will repeat itself at a certain point, right? Mhm. Mhm. Uh-huh. I see. Adriana, excellent. Very good. Excellent. Yeah, you got it. Yeah, Adriana, CG, Sarah, also very good, guys. Adriana, CG, Sarah, excellent, excellent. Good job. Right? They want the four derivatives. So I start with the first derivative. First derivative, easy because this is just a constant minus 4. The constant comes out, minus 4. And then I focus on taking the derivative of cosine of x, right? Cosine of x. The derivative of cosine of x is just minus sine of x. I simplify and I get for my first derivative minus or minus plus 4 sine of x. That's my first derivative. So now my second derivative should be the derivative of the first derivative, right? Derivative of this guy, 4 constant outside. Derivative of sine, cosine of x, right? Good. Third derivative derivative of the second derivative, right? So constant 4, derivative of cosine minus sine, right? So the third derivative in simplified form is this minus 4 sine of x, right? And now fourth derivative. What will be the fourth derivative? Let's write y, 2, 3, 4. This fourth derivative should be equal to the derivative of the third derivative of this guy. Minus 4 constant comes outside. A derivative of sine, cosine, right? So cosine. And notice, guys, this is the same as the first function, the original function. So this is very common when you take the derivative of trigonometric functions such as sine and cosine. Eventually, they repeat themselves. They go back to the original form, right? Because these functions are periodic. Yeah, very good, very good. So then you look through, and it's here. Mm-hmm. Very good, very good. Mm-hmm. Yeah, let's finish with this one that I wanted to demystify. They want just a second derivative, okay? So you can try, but if you don't finish, let me do it, okay? Hint, treat this as f, treat this as g, and just get the first and second derivative, right? That's it. Using this so-called product rule. Mm-hmm. Yeah, let's finish with that. Mm-hmm. Right here, first, this is this. Hint, let this be your function f, let this be your function g, and apply your product, right? Mm-hmm. Yeah, and while you work on that, let me write this as a note. Sometimes the students ask me, Professor, how do you know second derivative? Because of this number 2, right? The number 2, this indicates a second derivative, right? All right, let's do this together, okay? So derivative of f is just 7, right? Times the g function as it is, sine of x, plus derivative of g, derivative of sine, cosine, times the function f as it is, 7x, right? Very good, very good. That is the first derivative. I see students, Sarah. Sarah, very good, very good. You made my day. You got it. Yeah, perfect. Very good. We're headed there. Okay, so more students. CG also very good, right? It's not that difficult once you remember the basic result, right? More experience. Yeah, try to remember these guys for your homework. Oscar also, very good. I'm glad you guys got it. Yeah, great. So y prime will be equal to 7 sine x. 7 sine x. No. Yeah, Sarah, very good. Great, great, great. Yeah, 7 sine of x, right? Yeah, plus 7x multiplied by cosine of x. Professor, why you wrote this kind of switch? Well, there is this agreement, guys, that mathematicians have, right? That helps somehow to figure out the final representations. Simple functions up front, difficult ones or complicated ones at the end, right? But now this is the first derivative. They want the second derivative. Not a problem. I take the derivative again. The derivative of that first component, 7 sine x, is just 7 constant multiplied by the derivative of sine of x, which is cosine of x, right? The difficulty is to get this done. We have to apply the product rule again. But that's not that bad because derivative of f7 times g cosine of x plus derivative of g, which is minus sine of x, right? Multiplied by f as it is, 7x. Now let's just simplify this. 7 cosine of x plus 7 cosine of x minus 7x sine of x, right? Again, notice I'm switching the position of these two guys. Now, these are like terms, right? Cosine, cosine, 7 cosine plus 7 cosine, 14 cosine of x. And here minus 7x sine of x. And sometimes students ask me, why do you don't combine these two guys again? Well, because this is cosine, this is x times sine, right? Like a orange and apple, right? You cannot combine them anymore. So then you stop. You say, that's it. And this, guys, perfect match would be 14 cosine minus 7x sine of x, right? Very good.